So, all right. So today's session is on big data with Hadoop and Spark. It's an introductory session. So in this session, what we are going to talk about is first we will do an introduction of big data, what, why, and basically understanding the meaning of big data and how is it relevant. All right. So those who have already attended the introduction, they might find it repetitive, the first part. The second part, after the break, in the middle of it, around 9:30 p.m. IST, we'll have a 10 minutes break. After the break, we will talk about Spark and Hadoop ecosystems and architectures. We will go into the details of both. All right. So please introduce yourself using chat window, even though I may not be able to read each and everyone's introduction, but it'll help me understand your background. All right. And this session is being recorded, and the recordings and presentations will be shared with all of you. All right. And this is session 1 out of close to 18, actually more than 18 sessions on big data with Hadoop and Spark. This course, it's basically a specialization having two courses, Hadoop and Spark. First part of the course is focused on Hadoop, while second part, half of the whole course, is dedicated only to Spark. This course is probably one of the best courses available today online, live as well as recorded, and it's probably one of the most comprehensive course on Hadoop and Spark together. All right, it goes for close to more than 18 sessions. It goes generally up to 20 sessions. All right, so be aware of that part. So today's session would suffice as the introduction to big data technology stack. Everyone except myself is muted. Please ask your questions using the Q&A window. Introduce yourself using the chat window. Do you see Q&A window, all of you? And I'll read out the questions before answering, and I will also select your question in the Q&A window. All right. So please ask the questions using the Q&A window so that everybody is clear on which question I'm answering. Because other people might be having the same question, it'll be easier for me to answer that. All right. So please keep your messages short, but avoid chat language. Okay. It's okay to go a little more comprehensive, but please avoid the chat language. I'm really poor at the chat language. I'm not too great with the SMS. Maybe you can call me old fashioned, but yes. All right. So great. So great to have all of you in the session. And this is me, Sandeep Giri. I did my graduation from IT Roorkee, and I have mostly in my career worked on large scale computing. My first job was at DESHA, where we were having 10,000 nodes cluster, and we were churning humongous data even before Hadoop came into play. At DESHA is a company which is a heavily technology savvy. Amazon CEO is actually from DESHA. Jeff Bezos, who is Amazon CEO, actually worked at DESHA. And DESHA is we had been doing a lot of heavyweight lifting of the data in 2002. All right. And after DESHA, I joined a company called InMobi. And in between DESHA and InMobi, I founded a company called Tbits, and which was into document management. And at InMobi, we actually did a lot of heavyweight lifting of humongous data. We did machine learning using Hadoop and Mahat on on close to 200 terabyte of data. And we also worked on Cassandra and high performance computing at InMobi. Afterwards, I joined Amazon and worked there on the detail page as well as the image optimization of the detail page, the page from which you mostly buy things at Amazon.com. That's the page which I worked on at Amazon, and the framework which we built at Amazon is kind of very useful for distributed computing. All right. So at heart, I'm a software engineer and I love explaining technologies. I've even taught the programming language to my close friends. And so I love explaining the intricacies of the technology in as simple words as possible. And that's the reason why I started CloudxLab. And we basically wanted to build a company or a team who is passionate about imparting knowledge and helping people gain their career goals. So that's the personal goal for us at CloudxLab, and we are trying to gamify the education as much as possible. All right. So that's about me, Sandeep Giri. I'll be the instructor for this course. So I enjoy answering questions. Please feel free to ask as many as questions possible. I would love to answer the question. All right. So my humble request will be that ask as many questions as possible. Do not wait for the right moment for the question. I will answer the question as soon as I'm finished with a topic. Okay. Do not think that your question is stopping the session in any way or is delaying the session. Your question would be helping other people as well because they might have the same question and they are hesitating to ask the question. All right. So please, my sessions or these CloudxLab sessions are are around answering your questions. Okay, the content for big data may be available all over the internet, but the detailed question answer sessions and detailed analysis of topic is something which we take pride in. All right, so please ask as many questions as possible. Your questions are not stopping, or your questions are not delaying the session. They are the reason for these sessions. All right. Your question answers are the reason of these sessions. All right. So please ask as many questions as possible, and that that's the reason why we exist. Okay. All right. So that's about the today's session. The course objective in general, this is the first session of the course on big data. In this course, the end-to-end objective is to learn to process humongous data, the big data, with Hadoop and Spark, along with all the related technologies which are needed to learn Hadoop and Spark and processing big data. Okay, so this is the course objective. The course structure is that this is the live session, but along with the live session, you will get the videos, you will get the quizzes, you will get the hands-on exercises, and you will get the projects along with case studies. And all of these are based on real life use cases. The system that we have built is called automated hands-on assessment. We also call it AHA. The objective is to learn by doing. So you will get a challenge. You have to do it in CloudxLab. So there'll be a problem statement that you will have to solve using the Cloud Labs. And then there'll be an assessment which will check whether you have done it correctly or not. That is what is called as automated hands-on assessment. This is something unique about CloudxLab. So we are trying hard to build a very comprehensive system. And so far, the system is actually pretty good for learning Hadoop and Spark. So say, for example, here is an assessment whereby it's giving a challenge that login into CloudxLab. And here it's showing you the steps. And once you are done, you have to click on I am done, please check. Only then it will go and check whether you have been able to successfully log in. If you did not log in, it will not let you go in. All right. It will not let you go forward. It will give you that you have not been able to do it. All right. So this is about the my courses. You can, okay, this I'll like to skip. I think this we can discuss later. All right. Great. All right. Before proceeding with data variety, I'll just answer a few questions. There is a question. You are from computer science branch or information science branch? That is the question. No, I'm not computer science branch, but I have built far more complex systems than the usual um, computer science engineering. Okay, I'm from chemical engineering, but I have done a lot of computing in the college that you see even at the college, the college from which I passed out is IIT Roorkee. There is a group called Information Management Group. I am the co-founder of that group. All right, and I have done a lot of computing in the performance area. Good question. All right. There was one more question from somebody. We are going to cover MapReduce. That's the question from Hitesh. Yeah, not in today's session, but during our course. During our course, we are going to cover MapReduce. All right, but please keep in mind that MapReduce component of Hadoop is being phased out. Therefore, we have reduced the total size of the session on MapReduce, and we have moved the focus to Spark instead of MapReduce. Okay. Hiteshi's question is, when will be the next session? The second session of this course is going to be this Saturday. It's a course on Saturday, Sunday. So be aware that the next session is going to be this coming Saturday from 8 p.m. to 11 p.m. Our question is from Yogarani is, do we need database for structured data in Hadoop? I'll explain to you. As we go forward, we will learn. A question from Raghuveer, you teach only Hadoop administration. Also, actually, we do not have a Hadoop admin course. We have mostly the data scientist courses. We have basically two main courses, one hands-on with machine learning and other hands-on with big data engineer. Okay, in big data engineer, this course, the current one, the course on big data with Hadoop and Spark is basically a course for big data engineers. And the second course, which is on machine learning, is for most of the engineers who are trying to get into machine learning. We do not have a Hadoop admin course as of now. Question from Arvind, what would be the topic for Saturday's session? Saturday's session would be, Saturday's session will start Zookeeper. Zookeeper is something where we are starting, and then we will deep dive into Hadoop. All right. All right, Raghuveer. Raghuveer is looking for Hadoop admin. All right. A question is, I'm new to big data without much know-how. Would this be okay to attend the session? Yes. Today's session is for everyone. Today's session is for everybody. This session is fairly low. It's not too technical. We have tried to cover the basic use case, and we have tried to cover the basic architecture. So this today's session would help everybody. And please do not judge the course content based on today's session, because today's session is aimed for all kinds of users. Today's session is aimed for engineers who are new to big data, project managers who want to manage a project in big data. Today's session is for even the researchers who are trying to explore the possibilities in big data. So today's session is very open and very, what do you say, a little more theoretical than our usual sessions are. Great question, uh, Tanuja. All right. Question from Ganesh, where could I find the recorded videos? You can find the recorded videos on our website, and you can enroll there. Question from Anurag is, do we need to install any software for assignments? Very good question. Answer is no. Since Hadoop, Spark, and machine learning tools require a lot of installation, what we did was something interesting. That's where we started long back, that we came up with an idea called cloud-based lab, which is being used by many other institutions around as of today. And this is something which we started and is a unique selling proposition for us, that we have the most sophisticated lab available for which you don't have to install anything. As long as you have an internet connection and you have a computer, you can just connect to the lab and start working right away. All right, good question. Kiran's question is, will we discuss about Hadoop partitioning? Not today, Kiran, but you can leave a question at our discuss.cloudxlab.com. There we have a discussion forum. I would love to answer your question in detail. All right. Or if you are interested, you can enroll for the course. In that, we would be discussing in detail Hadoop partitioning. A question from Arvind. How big data will help in our real life scenarios? All right, we will answer it during our discussion now. All right, great set of questions. Keep the questions coming, and that's the only way to learn. All right, now, so let's start our discussion with basic definition of data. This is something really common terminology called structured, unstructured, and semi-structured data. There are generally, the data has been widely classified as structured, semi-structured, and unstructured. Structured means a data in kind of a relational database format, in kind of a tabular format, like you have in Excel sheet or in database. That the data is called structured. Why? Because we know what are the fields, right? What are the columns, and we also know their data type very clearly. All the records in such structured data, in such a table, all the records have the same set of columns with same set of data types. All right, that is structured data. The second is semi-structured data. Semi-structured data is where we have definition of fields, but their data types are not known. For example, the data in XML or data in CSV. We know that in CSV, what are the columns? We can separate the columns based on comma, and then but we do not know exact data type, right? So that's called semi-structured. Third one is unstructured. Unstructured is where we neither know the number of columns in the data, nor we know the data types of any of the columns, right? When we don't know the columns, that means we also don't know their data types. Say, for example, we have a plain text file. Plain text file does not have columns, right? That is unstructured data, all right? So half of the work, actually 90% of the work, is about cleaning up the data, arranging the data and cleaning up the data in any big data project. Applying the logic is just 5% of the total work, right? So this process of converting unstructured or semi-structured data into structured is called ETL, extract, transform, and load. There are many tools available in the market which do the ETL on the smaller data. Okay, say for example, Informatica, we have even there are many systems available for ETL for converting unstructured to structured, okay, or semi-structured to structured. Now, the question is what's the significance of the ETL in the new world? When this data, unstructured or semi-structured, grows bigger and bigger, the existing ETL tools are not able to solve those. That's where most of Hadoop and Spark come into play. That's what we will learn as part of the discussion ahead. A question from Arvind is, before I move ahead, there's a good question. Arvind's question is, what are the field data types? Good question. Question is, let's say have you defined a table in database before? When we create a table in database, we first of all define the we first of all define a uh, number of columns, like we define the column 1, column 2, column 3, and so on, and then we define the data type of each column. Okay, so that's the data type of each field. Does it make sense to you? All right, great, wonderful questions. Keep the questions coming. That's the only way you can learn. And you should ask question whenever you have the question comes to you, instead of waiting for the right moment. Okay. All right. So now the second thing, that second term that will keep coming again and again in our discussion is distributed systems or distributed computing. All right. And distributed systems means the groups of networked computers that interact with each other in order to achieve a common goal is called a distributed system. Let me reword it. So in order to solve a single problem, when one computer is not able to achieve the result, what you do is, instead of buying a supercomputer, you connect multiple computers together and then utilize all these computers to solve your problem, to achieve your goal. That's what is a distributed system. Okay. A question from Vinith is that, can you please give practical example? Practical examples are many. Let us say that you have, let's say you have a folder containing 50,000 of images. Okay, let's say you have a folder having 50,000 images, and what you want to do is you want to convert these 50,000 images into black and white. Right now, this problem, this kind of problem is really it's going to take a humongous time, right? Let's say you are working with, say, a website which has a lot of icons of people's profile pic, and you want to convert them into black and white, right? So you have got 50,000 images, and now instead of doing it on a single computer, what you do is you distribute these 50,000 images onto, say, 50 computers, right? Now, each computer, the way you run your program on each of these 50 computers to so that each program on every machine is basically processing 50 images, so not 50 images, only 1,000 images, right? Because there were 50,000 images and you had 50 machines. All right. So now it'll become 50 times faster. The whole process will become 50 times faster. All right. Does it make sense to you, Vinith? Great. Great. So this is an example of distributed system. All right. Great. Now, a question to you. So I hope the idea of a distributed system is clear to you. So a computer center, although it's a networked computers, is not really a distributed system. Why? Why is that? Because in a computer center, all of the computers are not involved in a single problem, right? They are working. They are basically independent computers. Are not really We are not really distributing the work amongst all the computers in a computer center, right? Correct. Thank you, Shiv Kumar, because they are not having the same goal. Great. All right. Great. Great set of questions. Keep such questions coming, and that's the only way to learn. Now, next question to all of you is, you can answer this using chat window. How many bytes are there in 1 petabyte? How many bytes are there in 1 petabyte? Okay. So that's right. So yes, so it's approximately 15 zeros after one. That is 1 petabyte. All right, 15 zeros after one. Okay, so good. Subhas has done let me just count zeros. 3, 6, 9. No, I think Subhas, that's a, a terabyte. Okay. All right. Great. So there are two interesting questions. One interesting question is, so there should be a software which distributes the work to other systems. Yes. And that software, sometimes you build it, or sometimes you use the existing platform or the frameworks or the software such as Hadoop or Spark. Okay, good question. And a program on individual PC which will take the work and execute. Yes. And that's kind of summary of most of the frameworks that you will see. Okay, great, wonderful answers and questions. Okay, now here is another question to you. How much do you think, just give a vague answer, it's not really relevant. How much do you think Facebook stores data in one day? How much data do you think Facebook stores data in one day? Imran says 6 petabytes. Karthik says 600 petabytes. So as per their numbers, maybe it is increased now. As per their numbers, they store around 600 terabytes. Wonderful, wonderful answers. All right, great. Now, a simple question to all of you is, what is big data? You can answer using chat window, not the Q&A. You answer using the big, all right? Using the chat window. So what is big data in your opinion? Just give your opinion. It's not necessarily have to be true. Okay. All right. Wonderful. Wonderful. So yes. So most of you are right. So big data is simply data of very big size. Okay, big data is simply data of very big size. All right, big data is not a tool, big data is not a process. Big data is simply data of very big size. All right, let's keep that very clear, because that's one confusion that keeps on happening. People keep on asking me that can big data predict this, can big data do this? No, big data doesn't do that. Big data is just data of very big size. It's up to us how to apply our technology on top of the data to achieve results. All right, so it's not the big data which does anything. Big data is basically data of very big size. All right, it just, when it moves, it's bunch of electrons, and when it is stored in the disk, it's bunch of polarized magnetic poles, right? Magnetic dipoles in the disk. All right, that's the data. That's the big data. All right, big as in big is an adjective, and data is usual data. Data. All right. Now, how big is the data when we say big data? How big? Big data is something that we cannot process using usual tools. And this is a definition that we are going to stick to, okay? So please pay attention. This is the definition of big data that we are going to stick to, all right? So that we cannot process using usual tools. What does it mean by usual tools? Usual tools means the tools that are not distributed, okay, that are not distributed, such as, say for example, your normal file systems, or your normal databases, or your normal or usual ETL tools. Okay, so data which is of very big size, so big that it can't be handled by usual tools, and you require distributed system to solve to handle such data. And what is distributed system? Something, a network of computers which can be used, which can be used in a way, or a software layer which basically this divides the work amongst many computers. Okay, distributed architecture is an architecture, or a software architecture which utilizes many computers to achieve a goal. Okay, so that's what is big data, and let's stick to this definition. So as part of this course, the course which we are talking about, the session 1 of which we are having now, this course will cover most of the big data tools. And, or in the other words, all the tools that are covered in this course are related to big data. Starting with Zookeeper till the Spark, everything is basically around distributed architecture. We will learn most of the philosophies around distributed architecture. All right, so let's keep the definition extremely clear, that big data, the way we will talk about big data, is data of very big size. All right. Now, before I jump to this definition, I will like to answer your questions. Okay, I'm just going over Q&A window. If you have not asked questions using Q&A window, please ask. Okay, that's right, Webhub. Okay. Okay, so I'm going through your questions. So Manikandan, Manikandan's question is, can you tell any examples which can process the usual tools? Some which can process with usual. I'll give you an example. So if you take an example of, say, the data of 50 gigabytes, the 50 gigabyte, or let's say few terabytes, and you want to just do very simple processing, it'll be difficult to get the reasonable results in time. Okay. Somebody has asked, can you please explain what is distributed architecture? Distributed architecture is, let me just go back. Please excuse me for a second. I'll just explain it again. The distributed architecture is basically a system having the distributed architecture, or the distributed system is the same thing. Okay, distributed architecture or distributed system is the same thing. Mostly distributed architecture means a software architecture in which we have groups of networked computers that interact with each other to achieve a common goal. Okay, in other words, programming multiple computers to solve a single or to achieve a single objective is distributed computing. Distributed computing, distributed architecture, distributed systems. I'll be using these three phrases interchangeably. All right. Tilak's point is it like in SQL, you cannot handle huge data because it will take ages to give you the results for your query? That's right. That's exactly the reason. All right, a question from Hitesh. Does this course cover CCP 175 preparation? Yes, this course actually prepares you for most of the data engineer or most of the mm, big data engineer kind of role. So most of the certifications are covered. That's the reason why this course is fairly exhaustive. This is probably the biggest course available online. The reason is that we did not miss out on one particular part. Okay. A question from Subhas: what is the difference between cloud computing and distributed computing? We will talk about it. In cloud computing, there could be one computer involved, while distributed computing, generally there is more than one computer involved. Good question, good question. Now, question from Pranendu is, does this cover machine learning? This course is specifically for the Hadoop and Spark, though we do have a couple of examples that involve machine learning, but we will just go over machine learning in this course for maybe say 20 minutes. Okay, so if you are looking for an exhaustive deep dive course or specialization in machine learning, we have another session, or the course is starting from 5th of November, and please join that one. Okay, this course is about the big data architectures and the big data systems. How do you, and both the things, machine learning and big data architectures, are kind of hand-in-hand systems and hand-in-hand technology. One prepares the data while other applies the algorithms on the data. A question from Partha: does this cover Thais? So Thais is a framework which is not, something too different from the usual. So you just have to enable Thais while doing the processing. Therefore, you can actually run Thais as usual. You don't have, but we don't do a deep dive into Thais. That's not actually generally required. Okay. Question from Sanjana: can you please explain how migration of existing ETL technology takes place in big data tools in MNC? We will cover that. Maybe remind me of this question towards the end of session. We'll have around 10 minutes in the end. I'll go over in the details. All right. It's a good question. I do not want to miss on that question. A question is it possible to create a Hadoop cluster in a single machine that is both master and data slaves? Yes, you can. All right, yes, you can. That's what is virtual machine about. When you download a virtual machine provided by all of these like Hortonworks or Cloudera, it has both master and slaves on the same machine. All right, but it doesn't make sense because the whole idea about big data, Hadoop, Spark, or any kind of big data computing, the idea is to divide the work amongst many computers, right? And if you're trying to do everything on a single machine, you may not get the feeling of the work distribution. Okay, and you will keep on questioning that what's the point? What's the point of doing this? We can do it better without Hadoop or Spark. All right. Great questions. Keep the questions coming. I hope others are also liking it. If not, please ask questions. That's the way we can all learn together. Great. Great. So our question is from Sekhar, AWS, Azure versus Spark. We will have 10 minutes for this question. This question requires a bigger treatment. So I would like to compare. So here AWS is a cloud provider. Azure is again a cloud provider, while Spark is a software, okay, which you need to install whether on Azure or AWS. That's my quick answer. Question from Hitesh, are we going to do Spark with Python in this course? Spark will be dealt with Scala in this course because that's what most of the student or most of the companies want. So as part of this course, the second half is dedicated to learning Scala and Spark. First, we will learn a language called Spark, and then we will deep dive into, first we will learn Scala, and then we'll deep dive into Spark. That's the second part of the course. Last 10 sessions of this course are dedicated to Spark and Scala. Okay, good question. Pranendu's question is, what is the difference between Spark and Hadoop? I'll cover this part in the second half. And please remind me by the end of it, okay? You will learn this part today. All right. A question from Sarma is that I'm losing interest on the session as it is more of for Q&A. So see, these sessions are for Q&A, and it's important to get the questions answered, because if the questions are not answered for the people who are asking, they will lose interest. So for general class, for everybody, it's important to answer those questions. It'll be great if you also try to answer the questions using chat window. It'll be great. All right. Thank you. I hope you understand. Because the only thing that we learn is actually by the way of asking questions. So I would not discourage or avoid any of the questions. And if you are already familiar with Hadoop and Spark, this session may not be right for you, because this one is the getting started session today. You can continue from session 2, where we go more into deep dive of Hadoop and Spark. All right. A question from Sivkumar, is Hadoop a secure technology that we can discuss later? All right, great. And great, we will talk about this towards the second part. A question from Tanmay is, will there be any hands-on today? Yes, we will in the, after we discuss the architecture of Spark and Hadoop, I will show you a couple of hands-on examples on CloudxLab, how to use Spark or how to use Hadoop towards the end. All right. Okay. All right, so good, great set of questions. All right. A question from Praveen that I need to answer before we go into, how is our language related to Hadoop? It's not related to Hadoop, okay? R is just like any other programming language, which lets you interactively execute expressions or execute the commands, okay? And so R is just another language or another programming language, while Hadoop is a general ecosystem for processing and handling and storing big data. Therefore, R is not related. But R is related in terms of R provides the largest possible library for machine learning tools. And generally, when we deal with data, The objective of dealing with data is to find the predictions, and that's called, a lot of it is called machine learning and analytics, and is done using R. Okay, Utkarsh, we will talk about the differences between Spark and Hadoop towards the second half. All right. Great set of questions. I can see there are very interesting questions coming up. I would love to answer your questions after a while. Okay, now the three characteristics that are quite common, and probably every article which starts with the definition of big data talks about these three things. Okay, so these are the three V's, although there is multiple other additions to this definition, but we will stick to the basic one. So when we talk about data, data could be at rest, as in it is stored somewhere, or data could be moving, like the way when I'm talking, the data is being transmitted from my side to your side. The variety data could be on many forms. Okay, so when we talk about big data is either of these characteristics, volume, variety, or velocity, if your problem, if your problem becomes impossible to solve using existing systems, then it's called big data. All right. So big data might be because of volume, velocity, or variety. Let's talk about volume. When we are trying to store humongous data, as in case of Facebook, you can see that every day they're storing humongous data, like 600 terabytes per day is what they're storing. And where it will be stored? It will be stored in some storage like disk or magnetic disk or solid state drives, right? Now, in order to handle such humongous data, the usual file systems will make it totally impossible to do so, right? Therefore, we will need to devise a system, or we will need to use a system in which we can store such humongous data using many computers. Okay, so that we can utilize many hard disks as well as many computers to store such kind of humongous data. This problem of volume is generally solved using a file system called Hadoop distributed file system that we will discuss later. So that's volume. The problem of storage is caused by humongous volumes of data. Now, the second challenge with data is velocity, data in motion. Data in motion could be in terms of imagine how many requests would be going to Facebook. How many requests will be going to Facebook from your phone? Everybody, probably most of you, even during class, are refreshing your Facebook page and trying to, or Facebook page is automatically pinging the server and trying to fetch new updates, notifications, or the feed, right? So imagine how many requests would be going to Facebook. Handling that many requests is, is basically handling the velocity, right? Similarly, when I'm speaking here today, there are around 70 people in the session. The video is being transmitted to 70 different destinations. And that's also counted as velocity. If there is a delay between from me to you, it is going to be very uncomfortable situation, right? That is velocity. Velocity is about handling the moving data. Okay, the third one is variety. Variety is data in many forms. Variety is data in many forms, meaning the problems involving the complex data structures, such as maps, social graphs, recommendations. Imagine that you have to find a way find a path from one point to another. Okay, imagine you have to find a path from one point to another. Even though the size of the map could be very small in terms of gigabytes, but the complexity is high. You have to try all possible combinations of all possible junctions and all possible paths, right? To find out the shortest path. Now, even though there is no velocity involved, there is no volume involved, still the problem will take a huge time to find while you try to find the path from point A to point B. This is called variety. This is called variety. All right. So in many terms, the variety also leads to the complexity, the complexity in the programs. Complexity means this program is going to consume a lot of CPU resources. That's called that generally the variety leads to the complexity. Okay. So there are many machine learning algorithms, there are many AI systems, even though the data may be smaller, maybe in few gigabyte size, but it becomes impossible to solve using usual systems. Okay, so that's called variety. All right, a question from Vineet. Um, One quick question, how Hadoop handles volume of data? How Hadoop handles volume of data is using a system called, using a file system called Hadoop Distributed File System. The session 2 of this course involves understanding Hadoop Distributed File System. Great. Or in other words, HDFS. Great. Vinny's question is, can you explain again? Probably you want me to explain the volume again. Which part do you want me to explain again? A question from Sanjana is, traditionally, veracity and value are related to big data, right? How relevant are they? They are basically added to the definition, but I'm not going to talk about those today. Okay, veracity generally means vague data and value means some value of data. So people have been adding these terminologies to the basic definition, and basically it doesn't make much sense when we talk about characteristics of big data. I'm really sorry if that hurts any of the definitions. Okay, but because we are mostly going to talk about solving the problem instead of creating noise, we are going to stick to these basic definitions. Okay. All right. So, all right. And a question from Maharani is that, can we replace MapReduce with ETL process? So ETL is a general term. ETL represents extract, transform, and load. Okay, so ETL represents extract, transform, and load, which means it's a general process. It's a general terminology whereby the same thing, ETL, can be achieved by many tools. Okay, MapReduce is just one way of solving. Sorry, MapReduce can also solve. MapReduce can also solve ETL kind of problems. Okay, and there are many other ones. But if your data is big data, as in humongous data of terabyte size or bigger, it is easier to get it done, or it is very much possible to get it done on time using MapReduce or Spark or Hive or other similar systems. Okay, good question. And all right, great, great. Wonderful set of questions. Keep the questions coming. It's actually only the way we learn. All right, now, a quick question to all of you just to understand, how much time does it take to read 1 terabyte from hard disk? That's right. It takes close to 6 hours. All right. Sanjana says it less than a minute. Sanjana, have you tried copying 1 terabyte movie from one hard disk to another? Okay. and you will know the pain of transferring data or copying 1 TB data from one place to another. It takes a lot of time actually, and I did not realize that how much time it takes earlier. Okay, approximately it could take somewhere between 6 to 10 hours based on how fast is your hard disk that you're using. All right. A question from Subhas is, it depends on various factors. I would love to understand what factors do you think it depends on? So my further question is, what factors does it depend upon? That's another question that I would like to understand. It's a good point you're raising. So you guys saying that and USB technology too. That's right. It might depend on USB technology. Okay. So let's talk about, when we talk about reading data from hard disk, we are generally going to connect a hard disk to a computer inside, which means it's going to be a SATA connectivity, not USB 2 or USB 3. Okay. And so yes, you guys right. So the connectivity does matter. So if you are connected via USB 2, it is going to be slower than USB 3, which is going to be slower than SATA. All right. So the hours which I'm talking about is based on that. All right. My humble request is please put your name if you want to ask a question or in the chat. That's my humble request. Okay, it's okay to just put any name. It helps me in answering the question. Okay. Question from Hitesh is, point from Hitesh is that it might depend on RAM, CPU speed uh, to handle to the read speed. Okay. All right, good point. That's a big confusion we have. So the read speed, the time taken to read data from hard disk does not much depend upon the 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 does not much depend upon the processing. Processor is generally idle while we are trying to read data, and we are here we're only talking about reading data. We're not talking about processing it. If you are talking about processing, then you were right. RAM, CPU, and the processing speed would matter if we are trying to process. Right now, we're just saying we just are reading the data from the disk and forgetting it. Okay, so all right. So I agree with Arun. It might depend on the disk speed. All right, and yes, also the disk in some way, but that's a very slight difference between multiple very different hard disk or different file systems. Okay, so if you are reading the data from hard disk, no matter whether you are using a supercomputer or you are using 100 GB RAM or using really high-end computer, still the speed would be in close to 6 hours only. Okay, this is a very important point, and this is something which we seem to forget all the time. Okay, that means that if your computer, your processing is taking 6 hours because you are reading 1 TB data, no matter whether you use very high-end CPU or GPU or supercomputer, your processing is going to take the same amount of time. Okay. The question then is, how can we make it faster? The question then is, how can we make it faster? And that's where the distributed computing comes into play. Either we use many computers or we used many different hard disks. Okay. So let me take you through a simple question. Let us say, it's a very simple exercise. Let us say you have to count just the vowels in that 1 petabyte data, but you have to do it every day. Do you need distributed system? Do you need distributed system in order to count vowels in 1 petabyte data every day? Just vowels. You just have to count A, E, I, O, U in humongous data such as a petabyte data every day. Okay, so petabyte data is 1024 terabyte, and 1 terabyte takes 6 hours. That means reading 1 petabyte data will take 6,000 hours, right? So do you need many systems to do it, or you can achieve using a single computer with one big hard disk? Okay, so Arun says no. Okay, I would like to understand in more details, Arun. All right. That's right. And here we are counting every day. All right, great, great. So most of the existing systems cannot handle it. As we discussed earlier, it takes 6 hours to process 1 terabyte data, and therefore 1 petabyte is going to take around 6,000 hours, and hence it's impossible to get such a work done using a single computer, and therefore we will need distributed computing. All right, does it make sense to you? Now, this is a traditional graph where we are trying to show that how digital storage has suddenly increased since 2002. 2002 is kind of the beginning of digital age, and after that, the digital data or digital storage has increased tremendously. All right. Okay, so here is an important question from somebody. So can I ask you queries later if I have, because I may have to leave during. Yes, you can come over to our discussion forum. CloudX, if you go to cloudxlab.com, on the right hand side, you will see discussions link on the menu. You can ask questions. I love to answer questions there. You will already find answers to your questions there. Okay. All right. So we have a pretty active community which people are answering on that forum. So feel free to ask questions there. It's going to be a more comprehensive and detailed answer. Okay. So now question is, here we talked about, is the data really increasing? Yes. After 2002, the data has suddenly seems to increase in exponential fashion. And the reason is, what is the reason behind such an explosion of data? On one hand, the devices have become faster, smaller, and cheaper. Okay, if you talk to any of the friends who are working in a hardware company like a smartphone or a chip, their agenda, their key performance uh, the key performance indicators are we making devices cheaper, faster, and smaller or not? That is their key performance indicator. So on one hand, the devices that you see right now, the phone that you use is actually more powerful than the supercomputers of 2002. So the devices have drastically become faster, cheaper, and smaller. The sensor that the phone that you have has more number of sensors that you have in a personal computer, that you have in a PC. It has more sensors, more ways of interacting with it than a personal computer. Therefore, more ways of generating data, and it has camera, it has gyro sensor as in movement sensor, it has GPS locations, it has such a huge screen where you can where you can actually touch and click. Therefore, the phone is a wonderful device which is more powerful than a supercomputer of 2002, and we use phone for doing very important things like playing Pokemon. All right. So the the second thing that made big data, the second reasoning is the connectivity. Connectivity today, everybody is having Wi-Fi, and people are having 4Gs, people are having 3G connections. There is a NFC and GPS, and not to forget the Bluetooth connectivity. So on one hand, the devices, whether smartphone, watches, or bands, or the IoT devices such as home sensors and monitoring devices, those devices become cheaper, faster, and smaller, right? On the other side, the connectivity has become uh, connectivity is omnipresent. All of the devices are connected. So if you think about devices as something that generates data, you can think of connectivity that transmits and multiplies data. So, and as a result, we got many applications on top of devices and connectivity, such as social networks, Internet of Things, and so on. Because of these reasons, because of software, hardware, and connectivity, we have humongous data to deal with. All right. So again, a very simple thing I'm going to take you through. This is important because it might sound very lame to most of us, but this is important to understand. Okay, so when we think about computer, we generally talk about four things. First one is the CPU. CPU is the processor. CPU is the processor which basically executes an instruction. Okay, and number of instructions it can process per second is said to be its speed. The second thing is RAM. RAM is random access memory, or simply we call it memory. Memory is place where we load the data and then we process using CPU, right? And because memory is extremely fast to read and you can jump anywhere as opposed to the storage. So the bigger the memory, the faster we will be able to generally process the data. Okay. So RAM is good, just that RAM is costly, and RAM, if the computer is turned off, all the data in RAM disappears. Okay. The third important factor that matters in case of computing is disk. Disk as in hard disk drive, or it could be solid state drive. Solid state drives are extremely faster, but they are smaller in size. The one that comes in the MacBook Air is solid state drive, and hard disk drive is a magnetic drive which rotates. Now, the third one, fourth one is something called network. This is something which we never visualize as part of the computer. Okay, so it's very important when it comes to dealing with data. Why? Because because let's say you're trying to do some processing. Okay, first you will load the data into the RAM, try to process it. If the data is not fitting into the RAM, you'll keep some in the RAM, some in the disk, and if it's not fitting in the disk, we will put it, push it to the network, and therefore, the faster the network, your overall performance is going to be higher. Okay, so CPU, RAM, hard disk, CPU, RAM, storage, and the network. All right. Any questions at this point? Great. And when we talk about big data, at least one of these components would become the bottleneck. In case of reading the problem that we discussed earlier, in case of counting the vowels, it's not CPU, it's not RAM, it's not network that became the bottleneck. It would be the discrete speed. And if we push the data to the network and we are reading from there, the network and the disk speed, these two will be the bottleneck in case of humongous data. All right, now here's the question to all of you. Which components out of these impact the speed of computing? Which of these impact the speed of computing? CPU, memory size, memory read speed, disk size, network speed, or all of the above. That's right. All of the above are the components which impact the speed of computing. All right. Not only the CPU. We have been sold the idea over and over again that CPU is the most important. If you don't believe me, then what you can do is you can take an old laptop and try to replace the memory and the disk with a solid state drive. You will see the drastic difference in the performance of your computer. All right. Increase the memory and replace the hard disk with solid state drive. You'll find a drastic improvement. Okay, there is a question from Maharani is it important to have a great spec for the components? So everybody wishes so. If I'm trying to solve a problem, I would like to have the best possible components available. But truth is, the generally you are limited by the budgets, and therefore you'll have to strike a balance. You'll have to strike a balance. Instead of buying really high-end computer, I would go for multiple computers instead of buying a single very costly computer. Because when you buy two computers, you will get CPU, double of CPU, double of hard disk, double of network speed, and double of RAM. If you say, so if you see the multiplier effect, it's far more as in buying multiple computers than buying a single computer. All right. So that's how you generally look at it. A question from Tanma, are we solving IO bound problems or CPU bound problems using big data? Okay, let's not use the term big data in this context. Using big data tools is something we can say. Generally, we solve both. Generally, we solve both, but mostly IO bound problems are something that we use Hadoop or Spark for. But if you look at machine learning problems, they are CPU bound problems mostly, and some of them are both IO as well as CPU. Great set of questions. And you're right, it's all of this, all of the above. Okay. Now, this was we talked about what is the we talked about basic definitions such as structured and unstructured data. We talked about the distributed computing. We talked about what is big data. We also talked about why the reasons like the hardware and the connectivity, as well as we talked about the we talked about the various components involved in computing. Okay, so now why do we bother processing big data? Why do we worry about processing humongous data? We could simply take a humongous data, keep a sample of it, and delete the entire one, right? That's what we actually sometimes propose, that let's just, if it's really huge data, we just keep the sample of it and discard the rest of it because we are not able to manage the amount of the money that's spent in keeping all of this data is just too much. So let's just delete the old data and keep only a sample of it and do the computing on sample of it. But no, the reason is the more data you have, the better insights you get. The more data you have, the better insights you get. For example, take a case of e-commerce recommendations. Amazon is able to give good recommendations and has demonstrated that if you give better recommendations, your chance of selling becomes higher. The revenue actually became improved more than 40% by the recommendations, specifically the recommendations sent in the email as well as shown on the web. So recommendations were great, but recommendations were not on the sample of data. Recommendations were on the whole data. That's why recommendations were great. If you do recommendations on small data, it's not going to give you a great result. Okay, now, so what is recommendations? Recommendations could be that people who bought this also bought that. Recommendations could be curated by people that people generally wear this with that. Or recommendation could be very comprehensive. For example, in Netflix, that we have found movies for you that you will love based on your past experiences. Okay, so this is something very important when it comes to big data. The bigger the data you have, the more the more the more precise recommendation you will have. Okay, if you have small data, the chances are you would not be able to come up with great recommendations. And how does it work? Recommendations generally work with a very simple basic principle. Say, say I like certain movies and you also like the similar movies. So we first find out the people who are similar to me, very closer in behavior to me based on the similarity coefficient. If me and you have watched more movies similar and we have rated in a similar way, that means we both are very similar, so we can happily cross recommend each other. So the more number of users we have, the more movies they have rated, the better are the chances of finding similarity and therefore giving great recommendations. Okay, so bigger the data, better would be the recommendations. Bigger the data, better would be the recommendations. Now, a question from somebody is that I observed it on Facebook. When I search anything on Amazon, it will reflect on Facebook. So that one is basically a recommendation, but it happens based on cookie sharing. Basically, Amazon, the ads on Amazon is sharing the information with Facebook. Okay, this particular strategy is called retargeting. In ad world, this strategy is called retargeting. All right, it's a win-win for both Facebook as well as Amazon because they're able to give precise recommendation to you. Great. So at InMobi, we built a recommendation, and our way was using the Hadoop, not Spark way. We used Mahat from Hadoop, and this is how exactly we did. So on one hand, we first prepared one kind of a listing whereby username, we created kind of, you can visualize it like a very simple way that you have 3 columns in the data saying this is the user, this is a movie, and this much they have rated. Okay, and based on this data, Kumar likes Matrix 4 out of 5, Kumar likes ISIS 3.5 out of 5, Giri likes Apocalypse Now 3.6 out of 5, and so on, right? And here, when we give this data to a machine learning library such as Spark ML Lab or Mahat, they give me the recommendation. These algorithms give me a recommendation saying Kumar would like Apocalypse Now this much out of 5, 3.6 out of 5, and so on. How does it do it? It basically finds similar users by comparing their movie habits and then start recommending the movies to each other. Okay, this is probably the simplest way to answer it. Okay, I hope this diagram is clear to you. Not clear? So here what we're doing is we first make a list of users rating that Kumar likes this much, this movie this much. And then we passed it to an algorithm such as algorithm from Spark ML Lab or Hadoop Mahat. That's what was used earlier, but now people are using MLlib more. And that one gives us the recommendation like this. Okay, this is how we actually built the recommender at NMOB. Okay, does it make sense to you? So this data that you see is the input to our algorithm, and this is the output. Now this data, preparing it in this form is really hard. If you think about Amazon, it'll be, the user ID will be the normal way. The user ID will be like, the user ID will be the normal way. And instead of movie ID, it'll be product ID. Which product do you like? And the rating will be either based on your actual rating, or it could be based on your purchase history. And we figure out, we just give it a rating. And it could also be based on which pages do you visit regularly. Okay, so this rating is something we compute here, and do a summation and do aggregation, and then we get the results. So preparing this data is largely the job of big data engineer. Okay, and then coming up with algorithm could be a data scientist person's job, and then we get the results. Okay, but it's not a rocket science. You can easily learn it, and you can start doing recommendations pretty easily. All right, now the second use case of having humongous data or big data is, second utility is doing things like A/B testing in e-commerce. What is A/B testing? A/B testing is testing A against B. Let us say there are two designs that you came up with. One is the green header, other is the red header. Okay, so what you did, instead of fighting over which color you like, okay, the idea is to basically compare the users instead of going with some designer's call. Okay, and this we did very aggressively in case of Amazon. So what we do is the 50% of the visitors, we send it to the variation A, while 50% of the visitors, we send to variation B. And then we observe where the purchases happen. Okay, as in this case, variation A led to 23% conversions, right? And variation B led to 11% conversions. So which one do you think is more useful, A or B? Which design will you go with, A or B? That's right, A, because A is giving you the better results, right? A is giving you the better results. Correct, Vinith? So if you see, variation A means 23% conversions. All right. Now there's a question called, idea is to find which that unmatch with both options of Kumar and Giri. You mean to say that the recommendations is also sometimes based on finding out which options of Kumar and Giri are unmatching, right? So yeah, there are a couple of algorithms. If you see, there is one thing called Tanimoto coefficient. There is a cosine, what you call, um, inverse cosine functions, and there are quite a few methods to compare two users with respect to similarity between the two users. So let's say we want to compare me and you. One way would be that we take all the movies which are similar between me and you. We'll basically count that and divide by total movies that we both have watched, right? That could be one simple way. That's called Tanimoto coefficient, while there are quite a few more complex systems that people have built in order to get more precise recommendations. All right. So there are quite a few algorithms. You must take a look at those if you want to know how recommendations actually happen. Good point. Very good question. All right, Tilak's question is, this part I did not understand though. Don't worry, because I kind of went into little more details to the question. All right, don't worry, you will learn as we go ahead. All right, great. So this was a very simple two examples. One is recommendations, where bigger the data, better will be the results. Now, question is, how does big data matter to in case of A/B testing? How does it matter? How does it matter? So how does it matter is that the more number of users you will have, the better it would be to compare the variations, right? It will be easier to compare. Imagine that you got only 5 visitors this side, 5 visitors this side, and they happen to all just like this particular variation. So you would not really get great results. So the bigger the numbers, better is the variance, and the better is the outcome. Okay, so maybe there would be idiosyncrasies, there'll be outliers, and so on. So if you have very small fraction of users coming to your website, or the A/B testing, if you're performing on a small set of data, it is not going to give great results. This is where the bigger the data, better will be the results of A/B testing. Okay, a question from Sanjana is recommendation similar to market basket analysis and association rules? So recommendation could be based on even market basket analysis. We could also start giving suggestions that people bought these three things together, and you have already put two things together in the shopping cart, right? So yes. So that's also a way of recommendations. Recommendations can be done in many ways, in many forms, not only using one particular algorithms. Okay. Recommendation is a general term to give suggestions to the users based on various indicators. Very good set of questions. Keep the questions coming. All right. Now, the other kind of users or the use cases of big data is in the government. Government can do in the government or in the usual banking systems, we can do a lot of fraud detections based on observing the data, outliers, anomalies, and so on. And based on the past records, we could generally come up with simple models which predict the fraud. Okay. Similarly, the cybersecurity welfare is another big area where if you keep on recording the activity of a user, and the moment you get an outlier in the user, you can always flag it uh, as something unusual and observe whether it's a security threat or not. The third one could be justice. Based on the past history of various cases, we could come up with a better judgment analysis. All right. Now, the telecommunication can improve. Whether it's government or whether it's telecommunication, the data, any data that we handle is humongous. Okay, any data that we handle is humongous, whether it's customers' data or towers data as in the maintenance parameters and so on. So all of that data is generally humongous. And to my amazement, probably last year, one of the companies approached us saying that they would like to do an analysis of the parameter or the configurations of each tower in telecom. And I said, yeah, fine. So we took a look at their configuration files, which were in XML, and I was amazed to see that the XML files were in hundreds of gigabytes. Okay, the configuration parameters, the history of configuration parameters at which they were changing for a tower were in gigabytes. So in telecom or government, almost every data turns out to be big data. So with the help of the data, we could always figure out why a customer is leaving. Customer churn prevention can be done based on the data. If we know how many times, for how long the customer was out of coverage area, how many calls the customer made to the customer support, what has been their history of usage, they were really using it, using the services or not, and so on. So based on that, based on the customer behavior, we could figure out why are customers leaving, and we could also stop them from leaving by providing better offers. So that's telecom. Then in telecom, we can also do network performance optimization. What is network performance optimization? That is basically figuring out how to route the traffic to make it more performant, okay, make it better. And that can be done based on the past history of the users, okay. So if we figure out a pattern that in the daytime, users are generally found here there are less number of users, and therefore the capacity planning can be done accordingly, right? Then the third one is calling data record analysis. The fourth one is analyzing network to predict failure. So if we keep the signals, the configuration parameters of all the devices and keep observing all the devices and keep the history of the failures, we can predict based on the behavior of the device that when it is going to fail. And therefore we can take a preventive measures in replacing a particular device before it actually fails. Okay, so those are the few examples of in the telecom. Next is healthcare. Again, just like telecom, government and e-commerce, healthcare and life sciences have humongous use of data. There are many, probably everything in healthcare is also having humongous data. Say, for example, health information exchange, the number of users are really too many, and the data related to an individual's health could be humongous. Similarly, if you think about gene sequencing, the number of permutations of genes are really humongous, and therefore most of the healthcare and life sciences problems are big data problems. Next is healthcare improvements and drug safety. All right, we will continue from here. After the break, we're going to talk about Hadoop and Spark. So let's take a break for 10 minutes. And back by 9:44 p.m. IST. Please post the time in your own time zone. So it is from 10 minutes from now is 9:44 p.m. All right, so should we start? Is everyone back? Is everyone back? Should we start now? You can respond in the chat window. All right, great. Great. So far, what we have talked about the what is big data and why now, as well as the use cases. And let's talk about how do we handle big data? How do we handle big data when it comes to solving a problem with big data, right? So since when you have big data, you will have to store it somewhere and you will have to process it. Therefore, you will need a distributed architecture, and hence you will need new set of tools, new set of frameworks to do the distributed architecture or distributed computing. So all of these solutions that you see here, whether it's Hadoop with Spark, Cassandra, MongoDB, Google Compute Engine, all of these are related to the distributed computing. Okay, so these are some of the examples of solutions of of handling big data. Let's say you got humongous data. Either you could install Hadoop with Spark and store the data there and process it there, or you can store it and process it in Cassandra, MongoDB, or you can upload it to Google's Compute Engine. You can upload it there. Out of these, the most complete solution and is something which comes as easier for most of the organizations who do not want to upload the data on somebody else's cloud, that it comes to Hadoop and Spark. That is most sophisticated combination of the available solution. Okay, so again, there was a question earlier saying what's the difference between cloud computing and distributed computing? Okay, let me first define what is a cloud. Cloud is nothing but computer at someone else's place. Okay, that's cloud. Now, cloud computing is doing the processing on a computer located on cloud, while distributed means doing the computing dividing the computing amongst multiple computers. That's distributed computing. All right. So those that was the question that was pending earlier. Now, so out of these, there is Azure. Let me just put the name here. There even say Azure, AWS, etc. Okay. These are another ways of dealing. I'll just put this here. Okay, because if I say Azure, the Azure's HD Insights is essentially Hadoop with Spark. Okay. So these are few examples of the frameworks to handle big data. Using these solutions, you can achieve the big data computing or distributed computing. If your data is really humongous or you're not able to handle your data using a single computers, then you can either set up your Hadoop and Spark cluster or set up Cassandra or MongoDB, or you can upload it to AWS or Google Compute Engine. Okay, Google Compute Engine, for Google Compute Engine to work on something, you'll have to upload data to Google Compute and then get the processing done there. Similar is the case with AWS. All right, so as part of this course, we are going to focus on this part. Okay, as part of this course, we are going to focus on this part. All right, so let's talk about what is Hadoop. So Hadoop was created by Doug Cutting, who was working with Yahoo at that point of time, and he was trying to build a search engine in his personal time. Okay, so he was later joined by Mike Caffarella, and they were kind of stuck. They were not able to make the progress because they realized that existing file systems were not sufficient to handle the data from World Wide Web. What's a search engine? Search engine is something that crawls the data of the internet and then prepares an index so that you can look up for the keyword really, really quickly. So when you search something, a search engine quickly looks in the index and gives you the result instead of going to the actual website to get the data when you need it. So search engine need to store a humongous data in order to prepare the index, and therefore they needed a framework. They needed a way to store humongous data and process that. At the same time, Google released these three papers. Google released these three papers describing their tools. One of them was Google File System. Google File System described how to utilize many computers to store data in the form of file system, in the form of files and folders. So that's what was Google File System GFS paper was all about, how to save data using many hard disks on many computers. And that's what became Hadoop file system. So Mike and Doug basically picked up these three papers and implemented them, and which is today known as Hadoop. And there was a second paper called Google MapReduce that became Hadoop MapReduce, and Google Big Table became Hbase. All right. So they implemented these three papers. Google did not publish the software. They just wrote a couple of articles, that a couple of detailed papers on the design of these three, and from which Doug and Mike got inspired, and they built Hadoop. It was named after the toy elephant of dog cutting some. Now, Hadoop started with these three components: Hadoop file system, Hadoop MapReduce, Hadoop Hbase. Okay, it became, although there were other similar tools or component, other teams who were working on the similar thing, but Hadoop was open source. That too with the license called Apache. Apache is a license which is very, very popular and which is very open. That means you can use Hadoop without having to worry about paying somebody, and also whether you are using it for commercial use, academic use, or personal use, it doesn't matter, as long as if a software is with Apache license. All right. So Hadoop is powerful, popular, and supported. I'll talk about why it's powerful soon. Popular and supported because there are many companies which are helping fix the bugs in Hadoop, and there are the implementers like Hortonworks, Cloudera, and MapR. These are few of the implementers of Hadoop. Okay, so therefore Hadoop is well supported by really good organizations, and therefore it is safe to use Hadoop for production kind of scenarios. Hadoop is a framework to handle big data. Hadoop is a framework to handle big data. So if you are we are so everything okay, so Hadoop started with these three components, but slowly it it became a umbrella in itself. It became a suite of component in itself, and more components were added under this umbrella. So eventually Hadoop became a framework to handle big data, and all of the components under this umbrella are distributed, scalable, and reliable. What does it mean? Distributed means they run on many computers. Scalable means anybody? What does it mean by scalable? Scalable. Okay. Expandable. Yes, I never think of it. It sounds like measurable. Okay, so yes, scalable is something that can expand, as in today you are handling, you are having 50 machines. If tomorrow you have like 100 machines, it should still work well. Okay, that is scalable. All the components under this umbrella of Hadoop, which started with three components, all of these components which we are going to talk about, all of these are distributed, scalable, and reliable. Reliable means if some of the machines go down, they still work flawlessly. Okay, so all of the components under the umbrella must also be written in Java. That was one of the rule which Hadoop was following. Great. Now, these are couple of these are few components. These are few components of Hadoop. I mean, almost all of these are there, just that Zookeeper is not here. Okay. The first one is a file storage. So these are the various components of Hadoop. Sometimes this diagram is referred as ecosystem, Hadoop ecosystem. Okay. And here the most important component in case of Hadoop is the file storage. The file storage. What does it mean by file storage? It's a place, basically this component of Hadoop called Hadoop distributed file system is the heart of the system. It's the basis for every other component. Almost everything in Hadoop is stored in Hadoop distributed file system. Like on your computer, you have C colon, D colon, right? Which stores files in folders. In the same way, HDFS is a file system which stores files in folders, but using many computers in your network. So if you are going to store petabytes of data, you cannot store in one machine. Therefore, what you'll do is you will install HDFS and install it on such a way that it runs on hundreds of computers. Okay, we will go into the details of HDFS. That HDFS got a master, that got a slaves, many many softwares running in parallel in order to give you a big file system in which you can store humongous data. So HDFS is a software or hardware? Anybody? HDFS is a software or hardware? Hadoop distributed file system? That's right. It's a software. Basically, it's bunch of softwares running on multiple machines and providing you a place to store data in a very simple way of files and folders. Okay, we will go into the details of HDFS in the upcoming sessions. We will understand why the design is, how the master and slaves work together. Most of these systems are in the form of master and slave. Master slave means there is one master and many slaves. If you have to get some work done using many computers, you'll have to choose one master and slave. Many other will become slaves. So this kind of model is quite prevalent, and in some cases such kind of model does not exist. Okay, the master slave model does not exist in some of the scenarios. For example, Zookeeper. In Zookeeper, the selection of master slave is automatic. Instead of you configuring it, there is an election in case of Zookeeper, and the election decides who is master, who is slave. Good. So Hadoop distributed file system is kind of master slave architecture, which has two pieces of software. One is master, other is slave. Slaves run on all machines, and master runs only on one machine. Whenever we want to talk to a file system, Hadoop file system, we talk to the master and so on. Okay, so we will go into the architectural details of HDFS and why should we choose HDFS, and we will also try to see if we can have an alternative file system better than HDFS. All right, so this is HDFS. HDFS is the main heart of it. So when you think of HDFS, you should think of many computers together providing you a big storage. Okay. Now, the next component is resource manager, yet another resource manager, yarn. Now, when you have many computers storing data, it will be wise to do the computing on the computer itself. Instead of transferring data to a central place, you would like to send the computing to all these machines which are storing pieces of data. So instead of transferring the data, you transfer the code, you transfer the program. That way, since the code is generally very smaller and the data is really humongous, that way transferring the code is extremely fast, and the overall results will be smaller than the actual data, and therefore the outcome will be parallel as well as extremely fast, right? So that's what yarn is. Yarn lets you execute program on multiple computers, right? HDFS is using, say, 100 computers. On those 100 computers, the CPU is free, the processor is free because it's not doing much work. That processor can be utilized by yarn for doing the processing. Now that processing, whatever we ask, could be of data or it could be not on the data, right? Some processing may not involve data. So in both the in both the kind of use case where we need data or don't need data, in both the cases we can execute that on yarn. All right. So using yarn, we can run programs in network. But since yarn is a very generic architecture, it's difficult to write. It takes a long time to write program for yarn. Therefore, we never directly interact with yarn usually unless we are creating our own frameworks. So we do not interact with yarn. We use systems like Spark and MapReduce. We write our logic for Hadoop, for MapReduce or Spark. That's the next computing layer. We'll talk about that one. The third thing is Hbase. Okay. A question from Yoga is, MapReduce is like a plugin in Hadoop or not? Yes, that's what it is. So let me just explain to you. So MapReduce is the compute engine. We write logic, we write our program for MapReduce. MapReduce internally give your logic to yarn, and yarn executes your logic in the cluster. Okay, so MapReduce is a way of, is a style, it provides its style in which you code, and it takes your logic, and you generally hand over the logic in the form of a job, and that job is generally made up of map and reduce. We'll talk about map and reduce, two pieces of logic, two pieces of function, two pieces of programs that we hand over to map reduce. It takes that piece of logic and goes to yarn and get it executed there. So MapReduce, we talk to MapReduce, we write our program for MapReduce, we write our Java code for MapReduce, or we write the Python logic or something. And MapReduce talks to Yarn. Yarn executes it on the same machines where Hadoop is installed. Hadoop meaning HDFS and the other components. Okay, so it executes it there. All right, so all of these things that you see on the screen is a computing software. All of these are nothing but services. Services, except for MapReduce. MapReduce is not a service. Yarn contains many services. Services means a software program that is continuously running, right? A service is something like a computer program that's running forever, listening to the input from the user and answering them, like a mail server, like a web server, or like a what do you say, like database. Okay, great, great. All right. Now, so we have yarn. Yarn is nothing but a question. Yarn is nothing but um, again a software which is we will go into more details later, to which you give your program and tell that, hey, I need this to be executed on 20 machines, and yarn will obey that. Yarn will talk to other computers and see if it can get your work done or not. Okay, so yarn will do the heavyweight lifting of executing your work on actual machines, while talking to yarn is a little difficult. So what we do is we use MapReduce. MapReduce gets its work done on yarn. It goes to, it takes your program and tells Yarn that take this map function, execute it on 5 machines, take this reduce function, execute it in 2 machines, and so on. So that decision where to execute what and how it is done by MapReduce, but actual labor work is done by Yarn. Okay, that's what it is. So it's not an interpreted language, it's just basically a gateway for the execution of your logic on many machines. Okay, so you yourself can also talk to Yarn and say, hey, I want this particular program to be run on 30 machines, and this particular program should be run near this particular data, and so on. That you can tell Yarn. So instead of you telling which file to use, how many machines to use, you don't involve in that. You say that here is my file, here is my logic now, and you give it to MapReduce, and MapReduce does the magic for you. All right. Yes, I've not touched Hbase. I'll talk about Hbase again. In the similar way, just like MapReduce, we have a new framework called Spark. Spark basically takes your logic and runs it on the Yarn. If Yarn is not available, Spark comes with its own resource manager that you can install on multiple machines. Okay, that that means that when MapReduce does not need to be installed on Yarn, MapReduce, you, whenever you want to run MapReduce, it will go and get executed on all the machines. We'll go into more and more details, exactly how does the entire magic happen during the course. It will be difficult right now to explain more details, but I'll try my best. I'll try my best. Okay. Now, now a question is, what is Hbase? So we understood that Hbase is, we understood that HDFS, Hadoop Distributed File System, lets you keep the data in files, right? In files and folders and so on, right? So it lets you keep the data in files, right? That's what HDFS does. Now, but not all kinds of data make sense to write in the file. If you want to continuously edit a particular record, what will you do, right? Let's say you want to update a particular record all the time. Then in case of file, how would you update a record? The only way is you kind of rewrite the whole file into another file and then change a record and then save another file and delete the old one, right? If you want to say delete a particular row, what will you do? You will take every record from a file and keep it in another file and delete a particular record and then keep it, right? That's how you generally dealt with records in the form of files, correct? If you will imagine that you are saving your data in the CSV, you want to delete 3 records, what would you do? You will basically programmatically read line by line, keep on writing to another file, and in case the records that you want to delete, you will not copy those, correct? That's how you deal with the records in the form of files. But that's extremely inefficient. That is extremely inefficient because even for changing a little bit record, a small record, you are altering the entire file. You are rewriting the entire file, and therefore that's not a great way. That's where systems like Hbase come into play, when you have to modify the data in the form of records. So Hbase is a data store which provides you the storage in the form of rows and columns. Rows and columns where you can change any cell anytime. That is Hbase. Hbase is great when you want to store data which has millions of rows and millions of columns. If your data has less than 10 millions of rows, your MySQL data storages are good, or your relational databases are good. But when your data goes beyond, say, 10 million records, then Hbase kind of solutions or NoSQL structures such as MongoDB, Cassandra, NoSQL data storages are the way to store humongous data. So Hbase lets you store hundreds of millions of record having thousands or millions of columns. That is Hbase. And Hbase internally stores the data in the form of files in a very clever way on HDFS on many computers. Okay, so Hbase is able to provide you this humongous data store, which can store hundreds of millions of columns and billions of columns, as well as millions of rows happily. How? It uses many computers simultaneously to store your data. And that's what we are going to learn in this particular course as well. We will learn how Hbase does it and how would you interact with Hbase in order to solve your problem. Imagine you building a, um, a system which requires you to save hundreds of millions of records. In that case, you would have to interact with Hbase. All right, Tilak, that does it make sense to you? Arun? I've not answered Scoop yet. I'll answer Scoop soon. Okay. All right, great. A question from Tanmay is, if we have to put Cassandra, should it replace Hbase in the picture? Yes, that's right, Tanmay. But I doubt if Cassandra stores or utilizes HDFS that well as compared to Hbase. A question from Annie is that, so the flow is Scoop Flume brings the data into HDFS, that's right. MapReduce processes it, that's right. And then where will the end result be stored? Good point. The result of MapReduce always goes back to HDFS. And using Scoop, generally you push the data from your HDFS into your relational databases. I'll take a case of, let me just complete this flow. I'll give you an example of my recommender engine. That'll give you an idea. Okay, so Tanmay's question is, so when we submit a MapReduce job, does it always get executed through yarn? Yes, that's right. It always get executed through yarn. Okay, a question from Arun was, is Hbase an internal database? Yes. Okay. If you want to create a DB table, then it's Hbase. All right, great. Great set of questions. Now, question from Yugarani is that if I have current database in Oracle, how will I use these Hadoop components? So you will use Scoop to pull the data. Let me just complete that part. Okay, let me talk about this. All right, so we had the file storage where we are storing humongous data, millions of files, and each file could be of terabyte size that you're storing on HDFS. Then we have Yarn, which can run your programs, run the programs or manage the resources of the cluster. If you have many computers, somebody need to manage those. Yarn is the one which will keep track of which one is busy, which one is free, which one is executing, and so on. And MapReduce is a form of running the program. You will write your code for MapReduce. MapReduce will decide how many computers to run and so on. And though we can control MapReduce, okay, so MapReduce is nothing but a humongous sorting engine. We will talk about MapReduce in detail. It's a little more programming involved. Now, okay, so now, there is Spark. Spark is a competitor of MapReduce. Spark has kind of replaced MapReduce in most of the cases, and that's why we have reduced our discussion on MapReduce, and we have moved over to Spark in more details. That's where the half of the course is dedicated to Spark. Okay, we will talk about Spark's frameworks after this discussion for some time. Now, since writing the MapReduce code was hard, because for every problem you cannot keep writing Java code or Python code, and there are many simple things like uh, SQL. SQL makes the life easier. It can help it for that. A lot of problems can be solved better with SQL. For example, if you have records, you want to filter them, group them, you want to join two data sets, you want to do all kinds of magic on humongous data. Writing code for everything is complex and takes time. Therefore, Hive was designed. Hive was designed so that you could run SQL queries and process your big data using Hadoop. Okay, so basically, whatever processing you were doing in the data warehousing, you can move that to Hive and can process billions of records happily. That's what is Hive. Okay. Similar to Hive, there was a tool called Piglatin. Piglatin provided a very simple way of writing code so that you can do the distributed computing happily. So Pig was the executor, Piglatin was the language, and Pig and Piglatin were designed in order to do the large scale computing in a very simple way like SQL. But because of the limitations, Piglatin has also been kind of discarded, not discarded, I would say, discouraged now because it took a lot of time. And personally speaking, we found that whenever we gave consulting to our customers, whosoever from the industry they came, so we found that solving a problem with Piglatin was always hard because it was a new language, not all the constructs were supported, and it was becoming harder and harder to keep on implementing new features because learning a new language was hard, right? Therefore, most of the computing of structured data, most of the computing of the form of SQL happens through Hive. Okay, so Piglatin is not in much use these days, though there are companies who have the legacy Piglatin script, they are trying to migrate. All right, so doing the computing with Hive became kind of de facto on big data. Why? Because most of the data computation in the industry is in SQL form, and running those SQLs on Hive was very much easier. All right, now same thing is moving to Spark SQL as well. We'll discuss it soon. Now, at a lot of time, we needed to run these complex algorithms, such as generating recommendations, finding outliers, and trying to predict future in in case of humongous data, we are trying to figure out what would happen next given the current state. That's where the machine learning came into play, or statistics came into play, and that's where Mahat came into play. So we Mahat was bundle of algorithms which internally run the things on MapReduce. So Mahat was a bundle of products, bundle of algorithms which provide you like things like generate recommendations given humongous data and so on. And Mahat was able to give you really great recommendations. I've used Mahat in case of InMobi, and to for a very humongous data, we were able to generate recommendations that was not possible before Mahat. Although Mahat is also moving to Spark. Now, in an organization, you have many tools. I'll talk about a workflow called a workflow of say recommender system. If you have a let's say a big project, you will utilize all these things, right? And to kind of stitch things together, we need a workflow engine, and that's where Oozie comes into play. It's not like BPM, it's more like Maven, Ant, Make, or some other kind of workflow engine. So Oozie runs these components in a sequence, okay, or parallel, or in certain order that you define. So when you have a large project and you have too many things to do, instead of you manually doing it, you write it in a workflow format, and that workflow will get executed as per your wish or as per the schedule. So that's what Oozie does. Now, the other components that we have not talked about are Flume and Scoop. What is Flume? When you have a lot of unstructured data, such as logs and other things, you would like to push that data continuously to a central place. Okay, so Hadoop file system sometimes is also referred as data lake. Data lake is a place where the organization's data flows to. All of the companies starts dumping their data to the data lake. Dumping as in pushing the data to the data lake, right? So HDFS, since it is a humongous store and storing data is really easy, therefore it becomes kind of a de facto for storing organizational wide non-transactional data. So for such cases, when you have a lot of unstructured data and you want to push that, copy that data continuously to Hadoop distributed file system. And this is where the Flume comes into play. Flume runs on many machines, let's say many servers which are generating data. You can run Flume there as a service, and it will copy the data to HDFS. Okay. The next component we have is Scoop. What does Scoop do? Scoop basically takes data back and forth between your relational database to HDFS or Hbase or Hive. So using Scoop, we can copy data from Oracle, MySQL, MS SQL, Microsoft SQL, and Postgres to HDFS, Hbase, or Yarn, or Hive, or vice versa. Meaning, you can also copy data back from here to here. All right. So you see that it's a whole suite. Now, when you have a ecosystem of so many components, there is a need for all of these. Let's take a case of say a workflow engine. I'm going to take you to the workflow quickly. All right, where did it go? Here. Okay. Now I'll just walk you through one use case, and then I'll take your questions. All right. So let me talk about what we did at, say, InMobi. So we had lot of logs. What is logs? Log is website website information stored in files. So whenever somebody accesses your website, whenever someone accesses your website, the server that serves that web page to you keeps this information, who accessed what. And that information is kept in files and is called as logs. So these are nothing but files. Okay, files where every record is having the user ID and other things. Now, we had these logs, and what we wanted to do is we wanted to find out who are these users and what they are looking for. What they're looking for. Okay, so based on the logs, we wanted to kind of prepare this data that which user is playing which game, okay, or using which app, how many times. So we were calling it rating. Okay, so based on the logs, we were figuring this out. Okay, and then and then and then we were handing it over to Mahat. Okay, Mahat was giving recommendations of, in the similar form, that this user will like this app. Let's say we have Tilak. Tilak was playing Angry Birds, and then Hitesh is playing. Hitesh likes to play some other game, and so on. So we have all the information about which user was playing which game at what frequency, and how much they love that game or app. Right? This information we extracted from the logs. Okay. We were into ad, so therefore we knew that which game is being played by which user. Now, we were passing this information to Mahat, and Mahat was giving these recommendations that Hitesh may also like to play Angry Bird, which Tilak was playing, and so on, right? So this way we were able to generate the recommendations. Okay. Now, this seems like pretty simple. So this process is called ETL, right? ETL, and this process is called collaborative filtering, or we also call it recommendations. Does it make sense to you? Does it look really ugly to you? Let me decrease the font. How can I decrease the font? Okay, never mind. All right, so we have recommendations generated by Mahan. This is what we were doing at the InMovie. All right, so now this one, let me just break it down again into another flow. So our data was coming from web servers using Flume. And let me just draw big HDFS. Okay, this is your HDFS. Okay, this is HDFS. So from the web servers, the data was going into HDFS using Flume. Okay, right? Does it make sense to you? The logs were going like this. And then from the HDFS, we were picking the data, and using MapReduce, we were processing it and then putting it back. Then using further processing was done using Hive. Then again, the output got saved back into HDFS. Okay, now the next processing was done by Mahat. Okay, Mahat. Let me just see if I can increase it. Okay, and Mahat again was reading from HDFS and writing back to HDFS. All right, now the next step, and this was the first step, this was the first step, this is second, this is third, this is fourth. Okay, and after that we were using what? We were basically, these were the recommendations. Mahat was generating these recommendations and we're keeping back in HDFS. And from here, using Scoop, we were sending it to our web server database. Okay, we were sending it to the database using Scoop. Okay, so you can see that in a typical case of any project, we generally end up using more than one of such components. Okay. All right, does that answer your question? Somebody has asked me this. Okay, now when you have so many things, the general way of managing this is using the Oozie. So Oozie was kind of workflow which was running this first. This was run continuously. It was running this first, then running this first, then running this first. Sorry, it was running this, then this, then this, and this. So it was Oozie who was running these components. All right, great. So So this is an example of using using the Hadoop ecosystem in order to solve your problem. All right. Now, uh, let me take a few questions here. So, Yograni, did I answer your question? If I have current database in Oracle, how will I use these Hadoop components? So you will use Scoop to pull the data into Hadoop ecosystem, and then you will do the rest of the computing. Good. All right. Now, uh, somebody asked that Scoop and Flume again. I think I've explained. Question from Tanmay is, can you elaborate Hive versus Impala versus Spark SQL? Let me try explaining Hive versus Spark SQL. Impala, I won't be able to cover today. Question from Aaron is that still getting confused. So the original and raw data will still be in HDFS, then be processed by MapReduce afterwards. Yes, so it can directly be also be kept in Hbase, and you can directly pick the data from Hbase using MapReduce. Okay, using MapReduce, you can process data stored in Hbase. All right, so you don't need to keep the data in HDFS. Hbase will internally keep on keeping data wherever it doesn't matter to you. All right, just like any database, like if you're using MySQL or Microsoft SQL, they also at the end of day store the data in a local file system, right? In C program files, Microsoft Office /data, somewhere it keeps it, right? So similarly, HBase internally also keeps data in HDFS. A question is Uzi equivalent of Data Factory in Microsoft? I'm not sure. I've not used Data Factory from Microsoft, so sorry about it. You can compare Uzi with Autosys. That also Autosys I've not used yet. Question from Carlos is how to use ETL in Flume. Do you have an example? Good question, Carlos. The ETL, Flume does not really provide ETL. The reason is Flume basically provides you a way to transport data. Okay, you can connect the sources and sinks and transfer the data using Flume, but Flume does not let you execute your piece of code in order to do the transformation. Question from Tejasri is Flume, MR, Hive processing is ETL again, right? So Flume is not ETL, but MR, Hive is counted as ETL. Okay, you are right in that sense. All right, sure. This video you will get, Tanmay. This video you will get, all right. Now, a question from Shama is Scoop mandatory to transfer data? I can see some components in ETL, yes, very good point, Shama, that there are many components. There are many components, they basically, so what is, what is Scoop basically? Scoop is nothing but internally it's a MapReduce job. It's basically a program which utilizes many computers to push the data to the usual database. Okay, and therefore you can also write your own programs to read data from HDFS and push it to database, or you can also use third-party tools to push the data from HDFS to DB. Okay, say for example, if you are working in R, you can directly read data from HDFS without having to use Scoop or any other mechanism. All right, very good point. Okay, so Tilak says that Autosys is just a job scheduler. So you can think of Uzi also is having a component called job scheduler. A question from Hitesh is, do we need Flume to use Spark streaming? So Flume Flume will basically push the data, but if you want to process a fast coming data, you can use Spark streaming with Flume. All right. So Flume will give you the data. Spark Streaming will continuously consume the data from the Flume. So Flume is like a big pipe. You could, the way when you think about Flume, you can think of like a big pipe in which the data can come continuously. Okay. All right. A very good question, Tanmay. Thank you for asking this question. Question is where Zookeeper falls in the whole scheme of things. Very good question. So this is something I keep forgetting and don't put it in this diagram. So Zookeeper is an interesting tool. Okay. Zookeeper is something which is used by HDFS. It is used by Hive. It is used by not Yarn. It is used by Spark. It is used by Kafka, and it is used by even Cassandra. Okay, it is used by Hbase. Okay, so they all use Zookeeper in order to coordinate. Okay, they all use Zookeeper to coordinate. All right. So yeah. So because HDFS is made up of many services, right? Many services, and when it needs to coordinate, it basically coordinates through Zookeeper. So Zookeeper is like a central tiny database on which you can write something so that you can coordinate with your peers or your master slaves. That's what a Zookeeper for. Zookeeper is a central place using which other systems can coordinate. All right. So Zookeeper is the heart of the game, and the whole system actually indirectly depends on Zookeeper. Question from Carlos. Thanks about streaming data. Kafka or Spark Stream can use ETL to transform data for logs. That's right, Carlos. Both Spark Streaming and Kafka can do this stream processing very well. Okay, so yes. So Tilak's question is it multiple processing runs parallelly in all? Yes, the processing always runs parallelly. That means it becomes really fast. Okay. All right, great. So I hope I was able to answer your questions. Let me see if I have more questions. I think this is answered. This is also answered. Great. And yes. All right. So this was our great. Is it clear to everyone? All right. Now, after a while, it was realized that I mean, similar to MapReduce, someone at one of the universities, Berkeley, they came up with Spark. I think it was Berkeley, right? I forgot the name of the university. So they came up with Spark, and they devised it in such a way. They devised it in such a way that it is fast and general engine for large scale processing. So Apache Spark is really, really fast MapReduce engine. You can think of it like this. It's approximately 100 times faster than the usual Hadoop MapReduce if done in the memory, and it's 10 times faster if it is utilizing only the disk. So Apache Spark is very similar to Hadoop MapReduce, but extremely fast, faster than the Hadoop. Okay, why it's faster? The usual assumptions which Apache Spark has taken are different. It utilizes the memory adequately in order to speed up the processing. Okay, it it speeds up the processing. So Spark does not provide a storage. It's a processing engine. It lets you do all kinds of processing, whether you want to process the data in the form of SQL, you are just trying to filter the data, join the data, and group the data, and so on, right? Or you're trying to do ETL, as in there's a raw data, you want to convert it to records. That also is very much possible with Spark. Similarly, if you are trying to do the computation of machine learning or very complex computation of predictive analytics or any other complex computation, you can use Spark. Okay? So a question from Rahul is, can Spark replace MR entirely, or still MR has its own necessity still? In my opinion, it does replace entirely. Okay, I'm being brutally honest, but yes, anything that can be done with Hadoop MapReduce, anything that can be done with Hadoop MapReduce can also be done with Spark. All right. Now, Hitesh, I'm answering your question very soon. Now, Spark can, now Spark in general is a computational platform. We give it a program and it runs it in a clever way that it runs using many machines and it runs it in a very fast manner. But since almost all organizations have Hadoop installed in them, almost all the organizations which are serious about big data have Hadoop installed them, which means they have Hadoop's yarn installed on the cluster, right? Therefore, Spark guys did a very clever choice. They made it possible to run Spark on existing resource managers such as Hadoop yarn. Spark can run on Hadoop yarn. Spark can run on Amazon EC2. It can run on another resource manager like Mesos. These are resource managers. What do resource managers do? Resource manager keep track of your cluster. What is going on where? Which one is busy? Which one is free? How many of them are there? And where is the data located? And so on. It keeps track of the resources of your network. So Spark can run on all kinds of resources, on all kinds of popular resource managers. And if you do not have any resource manager, then you can create your own standalone resource manager with Spark. Spark comes with its own resource manager as well, which means even if you don't have an existing cluster and you only are interested in using Spark, then you can install Spark independently without having to do anything else in your own cluster. All right. So Spark basically can run on all kinds of resource manager. Now, Spark does not provide you storage out of the box, but using Spark, you can read data from all kinds of data sources. You can read data from HDFS, you can read data from Hbase, you can read data from Hive, you can read data from Cassandra, as well as you can read data from Tachyon. I think it's called Aluxio. The name of Tachyon has changed. It's another file system like HDFS. So you can read data from all kinds of sources using Spark, right? Now, so Spark can run everywhere. Spark can read data from all kinds of sources. Also, Spark provides these wonderful set of libraries like data frames. Using data frame, you can actually do wonderful things. You don't have to write for loops and maps and reduces all the time. You can simply run R kind of queries or SQL kind of queries on top of data frames. We will learn all of these components when we go deep dive into Spark. Then if your data is coming really fast and you want to process it, you can use Spark's streaming library. These are the packages on top of the core of Spark. Core of Spark provides the ability provides these basic constructs which divide the data in the cluster, while it provides these user-friendly libraries using which the using which you can write the high level code which internally gets converted into raw or into the distributed way. So Spark streaming makes it possible for you to process data that's coming extremely fast. Now, the third library, which is very powerful and useful, is MLlib, machine learning library. Recommendations, finding recommendations, finding the doing all kinds of analytics, market basket analysis, and so on. There are hundreds of kinds of algorithms, starting with basic linear regression till the extremely complex systems. You have all the algorithms in MLlib. Using MLlib, you can do the machine learning using many machines, using hundreds of machines. You can utilize hundreds of machines to do machine learning. Since MLlib, the problems are generally complex and require many CPUs, it becomes easier to use MLlib on Humongous data to generate the insights that you're looking for. So had Spark MLlib been there, if I have to do recommendations, the same project that we did earlier, I'll use Spark MLlib. All right. Third component, very important component, is GraphX. What does GraphX do? GraphX provides you the algorithms on graph. If you are trying to understand the Twitter following graph or Facebook friends graph and so on, and the data is humongous, in that case, you can use GraphX. GraphX provides you not only the libraries, but also the constructs, with which you can process a graph. Okay, these are the libraries on top of the Spark. Now, the important part, this is something that I think would answer your question, Hitesh. You as a user can interact with Spark either using SQL, R, Java, Python, or Scala. So using your own language of your choice, you can interact with Spark. You are not tied to any language. As part of this course, even though we are going to use Scala, but the same thing very well applies if you are going to use Python, right? That's why it's very similar. Python Scala is very similar, and you will be able to, if you are good with Python, you will be able to go through the course very well. And if not, we are going to anyway teach you Scala in this course. So Scala, Python, Java, R, SQL. These are the languages with which you can interact with Spark's libraries. All right. So let me just read out the question from Hitesh. I heard earlier that Spark is used in conjunction with Scala, but nowadays they're moving to Python due to its rich libraries. So don't you think we should also cover the session with Python plus Spark? So don't worry, in the course, we are going to give you a hands-on with Python with Spark, okay? And it won't be too much of a hassle for you. Okay, so if some of the students want to go with Python plus Spark, I'll be open for that. Okay, all right. So Rahul, does that answer your question? Your question was, what additional features are in Spark compared to a MapReduce in addition to faster processing? So these libraries are actually rich as compared to MapReduce. All right, great, wonderful. All right, a question from Tanmoy. When Spark job is running, can another job write into Cassandra, Hive, etc. on the same machine at the same time? That is, they want fight for resources on the same machine. Good question, Tanmoy. That's where the job of Yarn come into play. So, because whether Cassandra or MapReduce is well or Spark, if they all of them are running through Yarn, then Yarn will do the management. Yarn has resource allocation, meaning on one computer don't do more than 4 containers. Let's say that's how we've configured our Yarn cluster, right? So Yarn will keep a track and will not schedule more than one job at the same time. Okay, and okay, so Yarn is the one who is keeping track of the resources and executing your processes, while Zookeeper is like a tiny database running centrally in which everybody is writing their information and reading the information from. Zookeeper, Zookeeper is that. Zookeeper is not somebody who is executing anything. Zookeeper is silently running in its own way, it and everybody just writing their data to it and reading from it. Okay, so Zookeep is this tiny database, all right, to which everybody keeps on writing their information and reading from it. All right, great. It's like a big whiteboard on which people keep on writing the information and reading from it. So that's how the job of Yarn is to keep track of what is running where, how much time it's going to take. Question from Hitesh, I see both Scala and Python. Found Python much easier than Scala. Scala is very difficult to learn. Not really. As you will go through the course, you will learn that it's not that difficult. But yes, I do agree that Python is probably the easiest language. Python is probably the easiest language, and therefore, uh, therefore, Python is generally a better choice for many data analysis. But here, Scala is exactly trying to do what Python did. Scala is kind of Java, somewhere between Java and Python. Okay, all right. The the advantage of Scala, those who are really curious, the advantage of Scala is that Scala compiles into the same bytecodes in which Java does. That's one of the reasons why Scala is actually faster. Okay, so that's the only reason why Spark core was written in Scala, and that's the reason why they preferred Scala over Python. All right, great. So Subhash's question is, what about command line interface, Java or Python? So basically in the diagram, it means that you can either interact with the components using the command line interface, or in case of Hadoop, you can interact with all the components using command line interface, using Hue. Hue is another interface, or using Java or Python or other programming language. All right. I hope that's what you meant. Question from Vijay, if it's not out of context, how much time in average it would take to install this whole setup? Okay, it actually depends. Okay, so for us, it took like a week or so to get everything in alignment. All right, in alignment, and it took me a lot of, and trust me, it took me, first time it took me like a week, then it took like 4 days, but we have installed this whole Hadoop cluster in CloudxLab uh, around 4 times, and we did it to optimize things. Okay, so even though it looks like easiest thing to do, but you might have to do it a couple of times to get things in align in tune. Question from Hitesh, Python is easier to learn for Java resource. Even Scala will be easier, don't worry. Okay. Can we use Java 8 features instead of Scala? Java 8 is, yes, people do use, we will talk about Java 8, how to work with Java 8 in Spark. But again, you will realize by yourself that Scala is actually extremely simplified version. It's like Python plus Java. So you will find that writing code in Scala is actually really, really quick. Okay, don't worry about the language. Leave it to me. We will learn it as we go ahead. Okay, don't worry. It won't be too hard. All right. So Arun's question is, I'm from admin background, which language will help me, Java or Python? Python will help you more because using Python, you can do a lot of automation. All right. Since let's take a case of CloudxLab, and we were going to do a lot of automation in administration. So we wrote CloudxLab entirely in Python so that it becomes easier to do a lot of automation. All right, and CloudxLab is in cloudxlab.com. Okay, can we install whole setup in a laptop? Yes, you can do that. You can download the virtual machine and do that. But the only thing is that generally virtual machines require these virtual machine setups that you can download will be like 10 GB in size. And when you install it, they will be like they'll be much memory hungry, and therefore it may not give you great performance on the laptop. So there are these setup issues that cause, and that's where we have set up CloudxLab so that anybody who wants to practice, learn machine learning, big data, or data sciences, they can just right away start. All right. Question from Aditya, if Scala compiles to the same bytecode for JVM, in what sense is it advantage performance-wise, ease of management? So yes, very good question, Aditya. So yes, when we compile Scala, it compiles into the same form as Java does, right? And there, the difference is the Scala does a lot of optimizations for you because when you write Java code, you can be inefficient at times, right? So Scala does those kind of optimizations for you. Second, Scala provides you a very simple construct, somewhere between Java and Python, right? Which makes it easy to write code, quicker to write code, and get it done easily. That's the reason why Scala is a preferred choice when it comes to computing with Scala is a preferred choice over Java when it comes to computing with Spark. A question from Vinith is, can I use CloudxLab? Yes, yes, you can go ahead and you can take a subscription of some time and use it. It is paid. So if you have already taken the class, you will get 3 months. You will get 3 months CloudxLab access, and that'll be good enough for you to learn everything. Okay. As part of this course, the you will get the live sessions like this one, just that they will be more focused on the course content and hands-on. And you will also get the recordings of all the sessions, like the way we are recording this session, we will record entire sessions. And we have also recorded the entire course in the studio so that you can really quickly learn from the recorded ones, because these live sessions, though right now they look really interactive, but if you try to listen to this later on, you might get bored. Okay, therefore it is better to listen to the recorded studio recording ones. Those are quicker. And the next thing that you get in this course is, other than the recordings and the other than that, you get 3 months lab. Along with that, you get a lot of quizzes, exercises in the LMS. And probably on every topic, we have a lot of exercises, hands-on exercises, and so that you can learn better. All right. So that's pretty much. So you can go ahead with the big data with Hadoop and Spark specialization course or machine learning specialization up to your need. If you are looking uh, for a career in the data engineering, or you're looking for a career in the big data, in the data sciences in big data, then this course will help you a lot. In this, we will cover the entire ecosystem of Hadoop and Spark. And it covers basically two courses. First part is Hadoop, second part is Spark. And it is probably best in class in the industry. So feel free to enroll. I look forward to see you in my session. So these classes are all on weekends. Okay, same time 8 to 11 and not on the weekdays. All right. Question from Subhas, Spark and other software are open source, do not require license. That's right. Now your question would be, why do we charge license subscription for CloudxLab, right? The reason is that we basically pay a huge amount to Amazon for hosting our services. Okay. So a question from Tilak is, when are the sessions starting? The second session, this was the first session, open. This is an open session for all. The second session is on the coming Saturday. So yeah. Question from Yograni is, Microsoft track certificate. Why do we go for this? Mm, I did not get your question, Yograni. Could you could you explain which what is Microsoft track certificate? Let me just take a look at it. All right. A question from Prasad is, any placement assistance is required? What we do is we basically connect you to some of the placement agencies we know, and we can help you prep your resume. So that's the placement assistance we can help you with. All right. How can I access this recorded video? It'll appear in your My Courses, uh, as well as we will send this to you in email. Question from Yograni is that one-on-one session. Generally, from my classes, everybody avails one-on-one session if they get stuck, or they reserve the one-on-one session for consulting on a project. So that's a part of the course. All right, one-on-one session for 1 hour. Okay, so question from Hitesh is, so now onwards, if I want to attend session, we'll have to pay? Yes. So basically, the session 2 onwards is paid, and there are few seats still left, so you can enroll. All right. Generally, our seats get full very quickly, so that's why. Okay. A question from Yogran is that, do you have training for the exam? So the way we have designed the entire course and trained the people is in order to, the training is focused on problem solving. Along with that, we have made sure that we cover all the certificates available, whether it's Hortonworks or Cloudera, both certificates are, available as part of the course. All right. Both actually 3 certification is what we have created the curriculum for. That's why the curriculum looks a little bigger, but it's actually complete curriculum for learning the big data engineering. Question from Carlos is, okay, if you have courses Spark at 7 p.m. RPST, please send me information. Okay, okay. So that one we don't have, Carlos, yet. We generally run only one course at a time. That's the reason. This time is what we have right now. Okay. But you can go for self-paced course if you are looking for at your own convenience. You can go for self-paced. It's Saturday, Sunday, yes. All right, great, wonderful. So yes, for the second session, you can enroll from the website and you can go ahead. It's up to you, Tilak. If you go for self-paced, you won't be attending the live one. You'll be only going for the self-paced studio recorded ones. And you can go for instructor-led. It's up to you. All right. I look forward to see all of you in the session and feel free to reach out to me. If you are a student, let us know. We have a separate discount for student and right. So we can help you with that. And if you are not able to afford it, we can help you with that. Don't worry. So as a matter of principle, if you're not able to afford, we can give you some discounts. All right. Question is, as I'm a beginner, it was very informative for me. Hope it'll be too much learning. It is going to be probably good time investment for you. I can assure you that. All right. All right. So please feel free to let us know how did we do in the session by providing your feedback. Okay. And yes, so we basically we provide our own certificate for the course. We do provide our own certificate for the course. And if you are really doing well in the project, if you do submit the project with us, uh, and we do involve you in our future projects. Okay, we generally have these industry connects going on continuously. Right now, we have 3 projects going on with the companies. So we can involve our students into those projects. All right. So feel free to reach out to us if you have any questions. A question from Hitesh is that do you guys linked with Cloudera or Hortonworks? There is another company called Hortonworks, which is similar to that. So what we have done is we have taken the best of both offerings of Hortonworks and Cloudera and prepared the lab so that people can prepare for all kinds of certifications. All right. I hope that answers Tilak's questions also. So we have our own certificate as well as we prepare you to all kinds of certifications available in Big Data. This course is kind of, you can say, union of most of the curriculums. All right, great, wonderful. Thank you, Tejasri. I'm very happy that it was the best investment of your time. Okay, so feel free to reach out to us. If you have any questions, let us know. All right. And come over to the discussion forum. We do answer here in the discussions. We answer a lot of questions. A question from Tilak is also, will I get your recorded sessions in self-paced course? In recorded sessions, as in we have the studio recording sessions, but if you want a live recording as well, I can share that live recordings of past. That's not a big deal for us. All right. Okay, so feel free to reach out to us if you have any questions. And all right, so thank you everyone. I enjoyed your questions. Keep the questions coming. Come over to the discussion forum or reach out to us over reach us at CloudxLab. And please do provide your feedback on the link that is provided in the chat. All right. Thank you everyone. Wonderful to have all of you in the session. It was great. Yes, yes, we'll share you as part of our process. We will share with you the recordings. All right. This live recording, this live recording along with the presentation will reach all of you. All right. Wonderful. Wonderful to have all of you in the session. I got wonderful questions. Great. So come over to the course. I can assure you this will be your best investment of time. And yes. A question is, I'm a high school student. Is that online certification enough for me to get employed in data science field? So if you take a look at the employability of this certificate, probably this is the highest rising domain. Okay, if you take a look at say Indeed.com, I was doing this analysis recently, and if you take a look at Indeed.com and take a look at the 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 employability of people who learn either Scala, Spark, or Hadoop, the employability is really high. Okay, so which essentially means that you'll be able to get employed in this domain, and to be able to answer the questions in the interview that we will prepare you during this session. All right, just that you'll have to work with us during this course. All right, a question is just that your this concern is that company may be more interested on university proper certificate. Yeah, that's also true. So some of the some companies are too much interested in the certificate or the university, but there are some which are interested in this as well. Okay. All right. Question is that if you are a fresher, then how to get hands-on? Good question. Good question. So it's a general question that when I'm a fresher and I would like to get a job, and most of the companies are asking for experience, right? This is where the most of the new technologies come into play. So the role that new technologies play is that since it's a new technology, having an experienced person is hard in that technology. Therefore, a freshman and a experienced guy is kind of on the par, and therefore new technologies help freshers to get into the industry. All right, and that's the reason why we have these kind of courses like Scala, Spark, and the other similar technologies. Right. All right, I wouldn't call Hadoop as a new technology, but yeah, Scala and Spark are. Did that answer your question? Great, wonderful set of questions. Feel free to reach out to us if you have any questions, as well as provide your valuable feedback. I look forward to hear from you. A question is, do these hands-on projects are to the industry standard? Yes. So, I mean, to be very honest, I started the entire thing so that people can actually get some real experience instead of hypothetical questions. That's the one of the reasons. The kind of things which we worked at Amazon, at InMobi, and eShop, those kind of works which we are involving here. All right. Great, wonderful to have all of you in the session. Feel free to let us know, reach out to us at, say, reach us at CloudxLab. You can enroll. There are still few seats left. Okay, so you can enroll. Great. All right, so should we hang up now? Thank you, everyone. Bye-bye. Have a good day.